Okay, so this could be our notes on electrical circuits. We're going to kind of make some of these tomorrow. Hopefully I can get back in school here. But you probably know some of this from middle school, and we're going to watch a video today on the basics of this. And then, but let me just give you the basic notes on this. So electrical circuits are really just like a controlled flow of electricity through a direct path. And so like we have a battery, maybe, just go like this. Then we have a wire. Then we have a light. And then we have back to the battery. Okay, so that's, we control where the electricity goes. It's through a wire, through a light, and then back. And it uses some basic things here. First one is a conductor. And a conductor is a substance that allows electric flow. I can actually go the other way on this one. So this one promotes electric flow. Sorry about that, I'm going to change that. So promotes electron flow. Substances have, and I think we talked about this the other day in the last notes, but some substances just, their electrons are easily removed, and those include substances like copper, aluminum, so copper, aluminum, gold, silver, lots of them. It's really easy to remove their electrons, so we use them to create wire. Some of them are more expensive, gold and silver. Probably wouldn't want to use those only in small amounts, such as in computers. But usually, if you look at a household wire, it's going to be copper or aluminum. But this is used for the wire, and it just, I'll explain in a minute how it works with the voltage, but the conductor is the pathway. And then insulators inhibits electron flow. Okay, so it doesn't allow it to flow. Usually plastic, glass, air is pretty good, rubber, and usually you wrap a conductor with these to keep the electricity within the path, because if you don't, they're just going to look for something else, some other substance to travel through. They're always looking for the shortest path. So if you don't have an insulator on the substance, then electricity won't even flow to the bulb and back to the battery. It'll just flow to a ground or to some other substance. So conductors and insulators are really the wire that it provides the path for the electrons to flow. And then we have something voltage here. Let me erase this stuff. So then we have voltage. And voltage is like the oomph, or the potential. Let me put that. So the potential. Of electrons to flow. So if you have a battery, let's say it's 1.5 volts, I think that's a AA, and what that means is electricity is going to flow down. It's kind of like a waterfall. The amount of energy in this battery is 1.5 greater than in the system. So you have a bunch more electrons here, and that results in it flowing. because there's a big difference. It's kind of like, gravity pulling these down. It's not really gravity, it's this electrostatic force. So, because likes repel and opposites attract, so if there's more electrons here, these ones in the wire want to avoid it, so then they then flow. And then based on how big this battery is, that causes it to flow really greatly or not so greatly. But that's voltage. And if you look at any battery, it'll have it. That's kind of how that works. And also, it has a power source. It could be a battery. It can be solar. It can be lots of different things. Wind. It can be, plug it into the wall. It can be generated by like a generator, or like an electrical company. Just plug your cord into the wall and there's electricity there. But it's a power source, and the power source is really connected to the voltage. It gives you this big difference in potential. And if you have a plug, one is usually bigger than the other, there's a big potential between here, between the large one and the small one. So when then you hook the plug in, it connects that difference and the electrons flow. And you could have lots of different ways to do that. A battery, you can just plug it into the wall at your house or whatever it is. Now, last thing we want to look at is types of circuits. And there's really two types, series and parallel. A series circuit has one path. And that means the electrons can only flow one way. So if you have a battery, it's kind of like a universal symbol for that. And you have a light bulb, and then you have a ground. Somehow that's connected to the battery as well. So we have a bulb here, or it could be anything really. There's just one path. So if anything happens anywhere in this circuit, the electricity will not flow and the circuit will not work, even if it comes after the battery. So if you have a break right here, the light will not light. And so always understand a series circuit is one path. They're real common for real simple things you need to light, like I'm trying to think, can't think actually right now, but just a single path, simple circuit. Maybe Christmas lights are an example of that. So let me erase this. That's a series. And then the parallel is actually a multiple path. This is the one we're more familiar with. And so you have it going to ground. And then, but here, you have a light maybe here, and a light here. Okay, so there's always cases where, if something happens right here, that's not going to light. But you can have breaks in the circuit, certain places, and it still will work. So if you had a break right here, electricity will still travel this path and still light this light. Or if you had a break right here, right here, right here, this one will still work. As long as this break isn't here, this one will still light. So parallel circuits give multiple paths for the electrons to flow. These are the kinds we have in our house. So if you plug your TV in and your light in the living room and some other things, if one of them circuits is not working, the other ones do still work. Now you might have circuit breakers in there for protection, and that might shut everything off, because all those different wires might be tied into one circuit breaker, and it might go off then. But it's possible in that room to have one of those plug outlets go out and the other ones still work, and that's a parallel circuit. And that's your introduction to circuits. check out the video as well that I provide you on Discovery Ed, and hopefully this is preparing you for the circuits we're going to build the next class period.